But suppose structural is there. In structural, this is not only static we are using. We are using the transient also, and we are using the explicit dynamics also. So means inside that we are using a different kind of analysis. And mostly, many times we are using the combination, because in our institute we are not using only structure or only thermal. This mostly times it is a combination of different physics. So either we can directly combine them, two physics together we can combine, or we can give in the sequential combination. Means we can solve for one physics, and then the results or the output comes from one physics, then it is given for the another kind of physics. Those inputs are giving another kind of physics. So as per the analysis types, it depends upon the physics. Either we are doing steady state or static things. If you are saying that we are aiming for end results and slow changes their body and not too much changes there, or the formation is not too high, or the temperature is not giving very high or something, slow changes there and end results, then we can go for the static analysis. But if the changes are very fast there, and these are changes are affecting our analysis or system, then we have to go for the dynamic or transient analysis. So as per the behavior of the physical phenomena, either we have to choose the linear or non-linear. So linear gives very good approximation for many physical phenomena, but very few physical phenomena truly behave in a linear fashion. If you will see the many different systems, they are not behaving in a linear fashion. So we have to go for non-linear reasons. This will give the very accurate results for geometric, metal non-linearity. If geometry has non-linearity or material are non-linear are there, then we have to go for non-linear analysis, and it gives very good results, but more complicated to set up. If we want to do the analysis, then setup procedure, pre-processing, and what kind of inputs are going, they are more complicated, and we have to solve them, then getting results. Mostly problems are coming for non-linear things. The convergence is not guaranteed that it is converging or not converging. Either it is taking so much time, but we have run some problem up to 1 week. Then we see that it is not, if it is converging, then we have to just reject that analysis and do analysis that what problems it is facing, and very long solution time it is taking, and a lot of computing resources, very high computing resources are required. We have the high performance computing facility here, so we are using that facility for, because our own systems will not work for the mostly of the problems, because more accurate and big data is required to feed as input here. This one application, just I want to show that we are doing suppose some analysis for that. This mechanical module we have used, suppose structural module we have used with the CFD. So cryogenic tanks, we have a lot of cryogenic tanks here in IPR. We have LN2 tanks, 3 storage LN2 tanks are there, which are horizontal, and 30,000, 33,000 liter capacity is there in each tank. And then we are having the helium, liquid helium tanks are there, GVARs are there, a lot of things. So this I am taking only the one problem here, that how we are approaching to that. So their tangent analysis with numerous startup and shutdown cycles has been analyzed. We have analyzed a lot of things without having the actual performance cycle, because in cryogenic tanks, if you will see, it is storing the cryogens, and then it is having the temperature effects for that. and within that, as the heat is always transferring from outside to inside, so heat is always inlet from that. So a lot of boiling is taking place always there, and this boiling will give the different kind of CFD inside that, and this can create the some vibration kind of things into that. So we have to check all those things when we are filling this cryogenics. When we are filling some tanks, the cryogenics or cryogen inside that area, then at that time the vessel is at the 300 degree uh, Kelvin, 300 Kelvin at that time. And when we insert any low temperature, and you can see any cryogenic tank has to be filled from the bottom, not from the top. Yeah. So we have to take care for all those things. So if we are filling from the bottom side, then it will give the low temperature is coming in contact with the high temperature. Immediately it will evaporate within this, and evaporation will take place, and different kind of heats will be there. It will convert into the vapor. The problem for the cryogenics is one of the problem is that uh, we are getting, if 1 liter of cryogen is there, and if it is evaporating, then it will become the 800 liters of the vapor. So you can see that one bar pressure, then it can go up to the 800 bars. So it is very slow. We have to cool down, and when we will cool it, then at that time this coefficient of thermal expansion will also play the role, because it will try to contract. So whenever it is trying to contract, then this all the loads will come into the legs or some support structures is coming here. So we have to cool down slowly, and then we have to fill it up. When it is filled up, then continuously heat is transferring to this, because you cannot make the any system which is the 100% insulated. So due to this heat transfer, every time some boiling is there, then it is converting to the vapor, then vapor is converting into the liquid. Some cycles are there. So we are using many kind of CFD process into that, that how the flow is consisting, how the flow is going through within that, and what kind of forces it is giving into that. So shutdown cycle, and then similarly we have to, when we have to means empty this storage tank, again the low temperature will become the high temperature. So this is the thermal cycling taking place. Due to this thermal cycling, a lot of fatigue stresses are generated into the cryogenic system, and tanks are this supports are very important, because temperature is changing will give the support height change, or and due to the contraction period, this and their lifetime also changing. So vibration, volume, and all the cryogenic tank is looking very simple from outside, but this is not outside simple. These are always the two layer tanks are there. So you can see only one layer tank. Inside that, one more layer is there. So two layers, they are connected with the different kind of internal support structure. So those support structures are also very important. And material property for those supports, strength of those supports, and other things, these are playing a major role between them. Otherwise, outside you will see that this is okay, and inside you will see then a lot of problems are happening within that. So analysis is making us to make to decide that what thickness of the supports are required, what kind of this, so that we can make the system very perfectly and within one go. Otherwise, if we will do R&D outside in prototypes, and sometimes we need small prototypes for making this, whatever we are getting the results from the analysis, it is working well or not. So This also I have given this little that what applications we are doing. So many applications we are doing. This is just one of them. Yeah. So I am going for my conclusions that fundamental concepts are very, very important before executing any kind of analysis, and we have to do some basic calculation for the new problem so that order of the magnitude can be verified. We miss this part mostly. We don't do any basic calculation. Directly we go for the analysis and we get some beautiful colored pictures for that. So this is not the case. We have to do some basic calculation. We have to try to benchmark the problem which is already given, which rates are known, just to have the confidence and to see the boundary condition assumptions we are making only for that purpose, and then use the appropriate solver so that simulation is fully converged. Otherwise, solver is not proper, then solution will not converge and it will not give proper results. So analyze the results properly so that you can interpret the behavior properly. If some results are coming, we are not able to analyze that, then we cannot interpret those results properly, and we cannot modify the system. We cannot see the efficiency of the system. We cannot give the performance of the system. So, and use the maximum features or tools for analysis to reduce the time. A lot of features are there which we have to go, which can reduce our time also. So, thank you very much for your time and patience. Professor Modi.
No, sir.
Yes, because I want that some interactive session or something, they can ask me any type of question. So that's why I made a little early this
Okay, sir.
pre-introduction.
We will unmute the participants so they can raise their questions.
Yes, yes,
Wait for 1 minute, sir.
yes.
Hello. Hello.
Yes, sir.
Sir, good morning, sir. Sir, actually, I wanted to know whether we have a very simple book even for the polytechnic students also to learn the FEM courses.
Yes, a lot of books are there in market nowadays.
Yes, sir. Very
There,
simplest, very simplest. Even polytechnic person who comes to the second year from the engineering can also learn easily.
Okay, so
Lateral entry.
yes, yes. One book from this NIT Ranchi, they have just now given one more book.
Sir.
Dr. Kaushik has given. So this is simple problem, but if we are seeing the verification manuals and other things, they are
Sir.
more simpler than these books are there, because a lot of process according to the answers they have mentioned, each and every step they have mentioned.
Sir,
So
sir.
for polytechnic, if they will go for the verification manual, then it is very good for that.
Okay, sir.
No need to go for very high books or something, but the basics we should know.
Yes, sir. Thank you, sir.
Okay, thank you very much. Any other question is there? Organizers are there?
Sir, sorry to disturb you, sir. One more question I have, sir.
Yes.
Sir, what is the difference between the online calculators that we have? If we type engineeringcalculators.com, we get different calculators wherein we have to just give the input and automatically the formula would be taken up and we get the output results. And the FEM solvers, because mostly what I have checked is they both give the same kind of results. So can we recommend online calculators as well instead of FEM also?
Yes, online calculators, if it is simple problems are there,
yes,
then yes, definitely you can use that. Should I on the camera or is
that's
okay?
fine for me, sir. No problem.
That's fine. Okay. So online calculators only for the simple assumptions are okay. If
Yes,
you are having a complicated geometry or non-linearity or complicated things are there, then you cannot use them. But
Yes,
yes, mostly general problems, suppose cantilever is there, simply supported, little small problems are there. But in that also we are not taking, we are just thinking that thickness is throughout the constant.
Yes,
Metal
sir. Yes, sir.
properties
Yes,
are
yes.
throughout the
That is for
constant.
symmetricity only. Yes, sir.
Yeah, symmetricity, and this is so at that condition we can use. But if we are going for the real time problem, then we have to take care a lot here. We cannot say, okay, whatever metal you are using, suppose you are manufacturing a lot of metals, okay?
Yes, sir. Yes, sir.
And each metal has the various range for that.
Yes, sir. Yes, sir.
And if you want to go for perfect kind of analysis, then we are taking the material and then we are characterizing it for different properties. Then we
Yes.
are using those property into our analysis.
Yes, sir. Yes, sir.
So, but this is a little higher kind of thing. For
Sir.
that, initially you can do with the standard things.
Okay, sir. Yes. Thank you, sir.
Okay. I've given mostly the practical aspect which we are taking care when we are doing any kind of problems.
Yes,
which
sir.
is not mostly written in the books and not told, not standard procedures are there. So,
Yes, sir.
at present also we are getting from ANSYS, we are doing some analysis, CFD analysis, and in that we have received the negative heat transfer coefficients.
Okay.
Okay, means heat transfer coefficient should be positive, but at certain geometry, certain place, certain flow, they are negative. So
Yes,
we have raised this problem to ANSYS, and ANSYS has raised this problem to developer, and till now it has not been solved.
Sir.
Still, that why it is coming and what kind of problems are coming. We know that what physics is going on, but how to correct those things into the software. So like that problems comes, and then we give the solution and other things, then they correct those things into the software, then they come back with problems. Okay.
Sir. Yes, sir. Okay, sir. Thank you, sir.
Okay, should I leave? Or
So if any participant want to ask question, please you all are unmuted, so you can ask the questions.
Divya, are you doing this first time? Yes, friend. Rinku, are you ready? Can you present?
Manoj sir, it seems like there is no question from participant sides,
okay.
so we can move ahead for the session.
Okay, if there is no question, then can I leave?
Sir, our session is planned up to 12, but if you have completed, then
Okay, up to okay, up to 12. I was thinking, okay. So if any question is there, then I can give in detail, or should I give some more insights if they want? But I have not made any kind of so much presentation for that.
you can give any more insight into the
More insight. Okay, okay, okay. I can give the more insight into the some problems. As we are doing, but presently we are working on the projects which is the Aditya project which we are doing. So suppose if this how many have worked on the superconducting magnets, or I think very few might have worked over that superconducting. So if we want to analyze, suppose some superconducting magnets are there, then we should know that which temperature it is going to be superconducting, because it will behave differently structurally and CFD wise at different timing zones. So if we want to suppose one conductor is there, should I on the camera on so that I can explain something? Huh?
Look, students, Divya and Rinku.
Are you able to see me?
no sir.
You are not. I have turned my camera on. Not
Black
able to see me? Yes, you have to do something.
No sir, you are not visible.
From my side, I have made camera on. I can see myself, but I don't know. Maybe problem from.
Ekta ma'am, please mute your mic.
Okay. So suppose some superconductor Sujan is there. If you want to design it,
मुझे बस वो चाहिए उसकी इक्वेशन
some noise is coming.
और अपने आप सब कुछ भी काम नहीं करते
Do you want to some settings so that you can see me and I can explain few things? Organizers.
Yes, sir. You just open your camera so we can see.
I have opened my camera. That's why I am asking.
But it is not visible on screen, sir. Sir, we have already given a permission to present your camera. Hello, Manoj sir, am I audible? Hello. Manoj sir. Manoj sir. Hello. Manoj sir, you are not audible.
Hello.
Yes, sir. Now you are audible. And
Yes.
your camera is also visible.
Video is also visible, na?
Yes.
Okay, okay. Some problem was there. So I was telling, suppose if you are going to design some superconducting magnets, okay, then this superconducting magnets has different kind of wires which are twisted in the nature. Okay, if you want to, are you audible to? I am
Yes, sir. You
audible.
are audible. Yes, sir. Yes, sir.
Oh, okay. So this magnet has the wire different kind of strands, and those strands are twisted in the nature. So we are twisting each and every strand over the different strands. Then it is combined in a one case. Then this case is the again bounded into the magnet kind of thing. Suppose if you are to make circular magnet, then this case within that a lot of strands are there, and all the strands are not direct strands. They are twisted in the nature within that. And then again we are making the some circular coil. So what is the requirement into that? That all these strands should not break in between when we are twisting them. So we have to do analysis that it should not break when we are twisting them. Second requirement was that when we are giving any flow from this, because superconducting magnets, they have to be properly cooled up to the temperature, whatever is their transition temperature. Suppose neodymium titanium is there, then their transition temperature is 9 Kelvin. Okay, so 9 Kelvin is there, then we have to cool them less than that. Less than means at least up to 4 to 5 Kelvin. So we are using the liquid helium for that, 4 to 5 Kelvin. So that 3-4 Kelvin difference is always there for that. So these liquid helium has to be produced for that. So one more system is required for this superconducting magnets, and in IPR we have the cold box where we can get that. So from one side, if you want to cool that magnet, then it is going into that case. Strands are inside, and then it is going to the case. This low temperature fluid is going to the case. This low temperature, if directly we are giving, directly strands we are cooling, then it is easy to cool them. But why we are twisting them? Because we want to make the heat transfer more effectively. Otherwise, the flow will be just like as a laminar, and we will not remove that heat from the strands. If we are not giving the good heat transfer, then it will not be cooled properly. And so that we have to twist them, but twisting should be that helium should flow properly, and it should give good heat transfer. And if things are twisted in this turbulent kind of things, then pressure drop is very high. So we have to check that there we want to give a balance optimization we have to do between all those things. Means it should be cooled also properly, and it's the pressure drop should also be less into that. Otherwise, if pressure is too high, then we need very high source of high pressure, and we are getting the low. This means heat transfer also is compromised. So both things has to be optimized properly. So we have given the twist also around 60% we have filled that case with the strands, and 40% we have given to the flow. So CFD was very important at that case, by which we can get the flow pattern inside that, how much cooling capacity it is giving and how much pressure it is giving. So both the things we have done the analysis, we have designed properly, and then from that this case having the strength, we have made the superconducting coil. So this is one kind of application we have done successfully. But when we have done CFD and this, at that time we have to see the electromagnetic. So we have coupled it with the electromagnetic analysis. And on that strands we have given the this current into that, then magnetic field generated into that. So the outer surface, the eddy currents were there and current were there. So magnetic fields is generated. So current and magnetic field, they have given the force on the case and on the strands also. So we have done the electromagnetic also, and from those electromagnetic analysis at higher temperature, the resistance was very high because it was not the superconducting temperature. The resistance was high. So at that time, this I square R heating was very high. Means a lot of heat has been generated into that. So we have to do not only one case, that at the case of superconducting, how much heat is generated, how to take out the heat. We have to see when suppose it becomes the high temperature, go to high temperature. At that time, the resistance will be high, and whatever liquid is there, cryogenic liquid is there, it will evaporate suddenly, and it will has to flow out from the system. So what are the restrictions are there outside? We have to open all the valves and something so that the pressure should not go very high, and whatever pressure it is going up to that level, then we have to restrict it by the case should not be blast at that time. So we have to design that case as a just like as a pressure vessel kind of thing. So you can see only if we are designing only a small part for that, but we have to see everything. Means we have to use the pressure vessel codes also, we have to use the structural analysis also, we have to use the thermal analysis also, we have to do the CFD also. So in each case, we have to see the combination of the physics or different kind of physics. But which physics is dominating mostly, we have to concentrate over that, and what properties are required in CFD, we have to concentrate over that. What metal properties are required, or if metal not suitable, then how to strengthen it with the minimum number of metal required. Because in cryogenic, you can increase the quantity of material, but it will not be cooled down. So then it will be very difficult, and it will take a long time. Then practical aspects, a lot of money is invested in the cooling down time. Yeah. So it will contract when it is cooled down, then again it will expand. So it should come to its original position. If it is not coming into the original position, means material selected, analysis done, design done, is not perfect here. So if we are going any analysis, then we have to see all the practical aspects. Second practical aspect, we have to see that it should be feasible for the manufacturing also, not only for the design and analysis. Design analysis, we can model any kind of feature, and those features can be used, but if it is not possible in fabrication, then it is very difficult. Suppose we have taken very high material, very low metal, then a lot of problems will come. Suppose in heater, whatever we have done, we have made the cryostat. The cryostat thickness came, because it is 30 meter by 30 meter. The thickness came around 70 to 80 mm of the plate, and from that plate we have to make everything. So many places we have used the stiffeners, but at some part we cannot use the stiffeners also, and we cannot reduce the thickness also due to the very high pressure requirements. Then we have developed the procedure for welding, that how to weld for 60 mm, 70 thick plates. It should be fully penetrating welding this. But again, the residual stress analysis we have to do, because whenever we are welding into that kind of things, then we have to see the stress remained after the fabrication. So for those stresses, we can take out from different kind of different procedures, but still the stresses were there. How much it can take, and what effects it will give further. So a lot of practical things has to be considered when we are doing the analysis. So analysis, when some person is doing analysis, he should not only know the only design and the software. He should know the fabrication procedure also. He should know how to join them, what kind of procedure for joining is required, how to install them, and how to commission. Means this designer and analysis has to know from very basics up to the last of the product. Otherwise, he cannot become very good designer or analysis. So only analysis, doing analysis is not one of the part for that design person. So we have to be very metal also. We should know that which metal we are choosing, how much it will have. So all the different kind of physics. And in our place, if we are doing mechanical things, then we should know the nearby electrical aspects. Also, we should know the this computing aspects also, that how the things wires will come into this, and then they will take the data. In our cryogenics, a lot of wires or sensors are there which we have to put nearby to measure the temperature. Suppose thermocouples are there which we are to put it, but all those wires will take the heat away, or outside heat can be penetrate up to the last point through these wires only. Yeah. So what should do? Otherwise, this different kind of heat load will come. It means we should know the wires also, how they are insulated, how we have to keep in there, so that we are doing anchoring of the wires, so that at last point it should not propagate the heat also, and it should not give the wrong results. So designer has to see all those aspects in practically, and then they have to combine it practically, and then do the analysis. Not only simple analysis has been done and it is over. So very critical things are failed due to not from these kind of analysis. I am giving one more example, practical example, which was lost to the one company, very heavy loss given to the company. We have designed something here in IPR, and we have given them for further, because they were expert in that. So we have told them to fabricate some liquid nitrogen pumps. What they have done, they have made all those pumps because they were expert in that pump, but due to some aspects, they have used one more material. So one more metal they have used. They thought, okay, both are behaving almost similar, so they have used it. But the gap between the pump and the body is very in micron level, and these two metals have the different kind of thermal expansion. When they have started it, and cost was one pump cost was approximately 30 lakhs. So when they have started the pump, they have broken that pump. So they have manufactured three pumps, then broken all the three pumps. They thought, okay, some problem was there, that's why it is. But later on, we have seen that they have used, instead of one material, they have used one more material which has different coefficient of thermal expansion. But they have not analyzed it properly, that material. So due to that, the heavy loss was there. So these are kind of practical aspects. We are facing a lot of things. So it is not easy to do the only design and analysis part. So whenever my suggestion is, whenever you are going to industry, or you are giving consultation to any industry or something, then you have to see all the practical things, how they are manufacturing, how they are joining, and how they are installing the things. So these are some more insights for the analysis part. When we are doing this, not only analysis, this is the concept from beginning to end. I think I have given something more to them. If there is a question, otherwise we can leave.
Participants can ask the questions. Any questions?
I think there is no question.
I think yes. But
Yes,
is
and if
item
they
just
want, they can send me the questions on my mobile numbers and my
sir, there
email
is one
through
question.
you.
There is one question in the chat box.
Okay.
What is the
Let me
difference
see.
between the, yeah,
Hmm. Tell.
what,
I'm not
yeah,
able
what
to.
is the, shall I say it, sir?
Ah, yes, yes, no problem.
Okay, yeah, yeah. What is the difference between the online calculators and the FEM solvers? Do they provide
Ah,
the
then.
same reliable and valid results?
Ah, I have given the answer to that.
Okay, actually, I was, my net was not there, so I was, okay, okay, sir. Okay, so I think there are no questions. Thank you so much, sir, for your resourceful lecture. The detailed design aspect report analysis and answers was discussed very nicely. Overall, the session was very fruitful. And thank you so much, sir, once again on behalf of FDP team and Government Engineering College, Bharuch, for sparing your valuable time. Thank you so much, sir, for our invitation.
Okay, thank you very
Good
much.
morning, madam. At what time do we have the exam, madam, today?
Yes, sir, that is what I am going to say now.
Okay.
Sir, the link for the test will be posted in the chat box of MS Teams at 3 p.m. as well as it will be posted in WhatsApp also. It will be at 3 p.m. It will be scheduled, and there will be 50 questions of 2 marks each. So the paper is of 100 marks. The test is 100 marks, objective type only.
Okay.
And it is compulsory for all of you to score 60 marks to get Atal certificate.
Okay, madam.
So yes, yes. So the link you will be able to find in WhatsApp, also in the chat box of MS Teams.
Okay, madam. Yeah, thank you, madam.
Yeah, yeah, yeah. Okay, so participants, we will meet at 1 p.m.
in the solar energy is there.
કોનો હે કે તારું પેલું ઓર્ડર લીધું હમણાં અહીંથી એમ ત્યાં શાસ્ત્રી રોડ પર જવાનો કંટાળો આવે આમ બી લીધું બેંકમાં જવાનું તો તારું બહુ કામ જા हेलो हम्म 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 अरे जो ऑनलाइन જોઈ લીધા এটা તારા સાહેબને કે ઓનલાઈન મળતી જશે મંગાઈ લઈએ હા ચાલો હું સાહેબને પડે ચાલો તમારું કરવાનું હા એટલે પેલું પેમેન્ટ અત્યાર સુધી તમને ખાલી બિલ જ જોઈએ ને એટલે બિલ જે ઓનલાઈન નો આવે તે જ રહે એ તો ઓર્ડર આપી કોલેજના નામે મંગાવે હા બાકી હું મારા બાકી તો જેનું એકાઉન્ટ હોય ને જે એકાઉન્ટમાં દાખલા તરીકે હું મંગાવું મારા નામથી આવે એમાં અંદર હોય ઓપ્શન ઓર્ડર ટુ એવી રીતના જોઈ લો ચાલો
બ્લેક જ છે ને આગળ ટૂંકમાં સિલ્વર જેવો
Deepa ma'am.
Hello, Doctor.
Yes, yes.
Dr. Vijay Kumar Dalla is with us.
Yeah.
Kindly start
Yeah,
the
yeah.
session.
Okay.
Welcome, sir.
Thank you, sir. Good afternoon to all the participants and Dr. Vijay Bhalla, sir. Dr. Kumar Dalla, sir, is Assistant Professor in Department of Mechanical Engineering at NIT Jamshedpur. His area of research is robotics, dynamics, and control. At present, he has published 14 research papers in reputed international journals and conferences. He is the lifetime member of Machines and Mechanism and Robotics Society. He has received MHRD fellowships for his persuasion of post-graduation and doctorate degrees. He has given many guest lectures in more than 35 institutes in the country, and he has conducted NPIU initiative TechWhip sponsored 150 hours training session on robotics and automation at the host institute for UG students of different domains. And we are very much grateful, sir, that we are having you as the expert today. I invite you, sir, to start with the session.
Yeah, thank you, madam. Thank you very much. And
Welcome,
thank you,
sir.
dear coordinator. Thank you, dear coordinator, Modi sir, for giving me this opportunity to interact with the participants. My today's topic is FEM in robotics. So, which just I'm going to start. Give me a few minutes only. Just there is actually there were connection. Also, power was not there. That's why. Yeah, just give me a few minutes. Ma'am, which type of participants means whether are
Sir, they are faculty members
Yes,
from
sir.
all over India, sir.
okay? And how many participants from the own institute?
So from my institute, there are 10 participants.
Okay, okay. Actually, sir, I am not at NIT Jamshedpur. My vacation is going on. So I am at my in-laws' home. That's why, yeah. Yeah.
मैंने ना गूगल स्कॉलर पे अपनी प्रोफाइल बनाई तो उसने आता ना सेलेक्ट तो है ना उनको समझ ही नहीं आ रहा कि अपना जैसे प्रोफाइल बनाया ना बहुत सारे और 5,000 साइटेशन
Sir, are you facing any
Yeah.
problem?
Just.
Sir, your screen is visible now.
Yeah, sorry for the inconvenience. Actually, I'm not at the campus of NIT Jamshedpur, so even I'm dealing with a different system computer. It is my own, not my own computer, so there's a problem. Yeah. So thank you for the invitation. What I have done, FEM in the robotics system that I am going to expose. Yeah. Firstly, I am Dr. Vijay Kumar, I have done my PhD, my PhD, in which I also used artificial intelligence in robotics like a genetic algorithm for optimizing the trajectory, and I have used the software bond graph, the bond graph technique, in which I have used the numerical methods, Runge-Kutta method. So whatever we get get solutions of in the robotics, analyzing a robot and getting the trajectory, avoiding obstacles. All I have done with the help of software. The software name is Symbols. Okay. And regarding this, later, my student, my MTech student, he is now with IIT Jodhpur. He worked in FEM in the robotics using SolidWorks, using ANSYS, SolidWorks for preparing 3D model and extracting data and analyzing the system. For that, ANSYS is used. Okay. So, I have divided my lectures into two parts. First, the basics of FEM used in robotics. Then I will go to the software exposure. The software name is RoboAnalyzer, in which we will see the motion of virtual robots, like kinematics and the dynamics of a robot. So, in this way, I have divided my lecture in two parts. So, please bear with me. And regarding this finite element method, so obviously it is the fifth day, last day. So, you all are aware about the basics of FEM. But what about the applications in different domains? Can we use it? In the case of robotics, where accuracy matters. Like suppose a robot is drilling on the wall, or robot is doing some other critical work like inspecting a pipeline, inspecting a pipeline. So in that case, the robot needs to go inside the pipeline. So suppose for surgical application, you might be knowing a robot can go inside a stomach, can take peaks, and also can do surgery. So in that case, is it possible if you use approximation method, numerical methods like FEM, where accuracy is concerned? Okay, so my answer is, however, we don't get accurate answer. Answer means accurate position and orientation of the robot. So in that case, we can minimize. We cannot avoid completely, but definitely we can minimize the error. And what is that error? The error between the reference velocity and the actual velocity. Means the deviation from the actual location. Okay. So coming back to this FEM, the finite element method is a numerical technique for finding approximate solution to boundary value problems for partial differential equation. In simple terms, FEM is a method for dividing of a very intricate problem into small elements that can be solved in relation to each other. It is useful for problems with complicated geometries, loadings, and material properties where analytical solutions cannot be obtained. In many cases, in robotics also, for the complex kind of robot like multiple degrees of freedom and having 3 degrees of 3 dimensions, in that case, it's very difficult to analyze. So in that case, we can obviously opt the finite element method. And regarding history of FEM, so I think I no need to discuss all aware, but still the finite element analysis was first developed in 1943 by R. Cohen, who utilized the Ritz method of numerical analysis and minimization of variational calculus. A paper published in 1956 by M.J. Turner, R.W. Clough, S.C. Martin, and L.J. Clough established a broader definition of numerical analysis. By the early 70s, FEM was limited to expensive mainframe computers generally owned by aeronautics, automotive, defense, and numerical industries. The subject is now being taught in UG and PG courses. Nowadays, it is interdisciplinary, and we need to gain knowledge and can be utilized in mechanical domain, civil domain, mainly in mechanical for analyzing the beams that in that case we can use. Okay. So working of finite element method, it uses a complex system of points called nodes, which make a grid called a maze. This maze is programmed to contain the material and the structural properties which define how the structure will react to certain loading conditions. Nodes are assigned at a certain density throughout the material depending on the anticipated stress level of a particular input. Regions which will receive large amount of stress usually have a higher node density than those which experience little or no stress. And regarding types of finite element method, finite elements, so it may be either 1D, 2D elements, and 3D elements. Mazing in FEM, maze is your way of communicating geometry to the solver. The accuracy of the system is primarily dependent on the quality of the maze. The better the maze looks, the more accurate the solution. Okay. So it depends how many nodes, means the better to divide it in the number of sections. And that depends person to person. meshing also depends person to person. As a resultant, also we get the solutions. The solutions mean which is more closer to the exact solution. And the FEM nodes used for meshing. So, like 2 nodes, linear, 3 nodes, quadratic, 4 node, 2B. That is in the case of beam truss elements. For triangular elements, 3 nodes, 6 nodes, 10 nodes are used. Okay. The beam element used for meshing, the beam elements typically fall into 2 categories, which is able to transmit moments or able to transmit moment, or sorry, not able to transmit moment. Okay, one is able to whether it is able to transmit, and another is whether it is able to transmit or not able to transmit. I'm moving it because all these are, I assuming, have already been covered. And what are the benefits of FEM in simulation? Because we are dealing this in modeling and the simulation, so you might be knowing about the difference between modeling and simulation. Modeling is what? The representation of any physical system, either in terms of mathematical modeling, or in terms of a block diagram, or in terms of graphical representation. And simulation is what? Is the way of validation of the proposed model. Okay. So through the simulation also we can predict the behavior of the system.
Sorry, sir.
Behavior.
Sir, sorry, sir,
Yeah.
sir, sorry to interrupt you. But your presentation is not visible, sir.
Not visible?
No, no, sir.
Okay, okay. But I have shared, ma'am. Just
No,
one.
yeah, yeah.
It's still not visible.
No, sir, still not visible.
Oh, just one. But I have shared.
Yeah, yes, it is now visible.
Yeah. Now. But they also have shared it. I don't know why.
Yes, the presentation is visible, sir.
visible, na? Okay.
Yes, yes, sir.
So, yeah. What I was saying, the difference between modeling and a simulation, and how to validate the proposed model. So, simulation is one of the way to validation in virtual mode. For the actual, then we can go for the actual validation, means experimental. But this is also one of the way to validate the system. So, regarding benefits of FEM in simulation, so reduce the testing and redesign costs, thereby shortening the product development time. This is the beauty of simulation. If you directly do some experimental work for the validation purpose, so we need space for that, we need time for that, we need to afford the setup cost, and suppose failure occurs, then it becomes difficult. It becomes expensive. Identify issues in design before tooling is committed. Okay, if there are some issues in designing, like designing a motor, so how much power of motor is required? Okay, and how whether the link of the manipulator is able to sustain, able to bear the applied load. Okay, or you can say the reactions of the manipulator, whether it is able to cope up or not. So that kind of things easily we can identify. Refine components before dependency to other components to avoid changing. Optimize performance before prototyping. Is there any possibilities to optimize? In the case of robotics, optimizing means whether we are able to save the fuel required to run the motor, required, suppose in the case of satellite, for the service life of the satellite, whether we are able to optimize the path. Okay, sometimes intermediate path is not required. In that case, start point or goal point matters. Okay, so can we optimize? That I have done by using genetic algorithm, and I also published in paper. One can access that. Next, discover design problems before litigation. Okay. Before the building of actual model prototype, we can discover the various problems associated with the manipulator. So basic steps implemented in FEM. So you all are aware, but again I'm repeating this. Discretization first, very first. Selection of approximation of functions. Formation of elemental stiffness function. formation of total stiffness function matrix. Firstly, the total system, total manipulator is divided into small sections. So we need to formulate stiffness for each and individual section or element. Then we need to integrate so that we can get a total stiffness matrix. Then formation of element loading matrix. Then again, it is for total loading matrix, formation of overall equilibrium equation. Then implementation of boundary conditions. In the case of robotics, we can find out the boundary conditions and apply like our trajectory means we need to for the trajectory is a time dependent equations. So in many cases we need to use the certain trajectory like a B-spline curve, Bezier curve. So for that we need to select the control points. Okay. So in that we need to know the boundary conditions, lower bound and the upper bounds. That is one kind of limitations. The system. Then calculation of unknown nodal displacements. Okay. Suppose there is a deflections. We are going to study the deflections in the link of the manipulator. However, generally we study about the rigid bodies, but in the actual cases, rigid bodies may not be applied in many cases. The flexible manipulator is required. So in that case, we will be knowing about displacements of some nodes, but obviously some cases, some displacements we need to calculate. Then finally, calculation of stresses and strength. Okay, so just like a beam, we can know about stresses developed in the manipulator and the strengths as a result in developed in the manipulator. Because a robot is not only limited to only for one application. It can be used in very complex environments, like dealing very hot object, very cold object. So there may be sudden changes in the its stresses and strength. It may go in the space. It may assemble the parts. It can weld. If you see, like in Tata Motors, we have visited. So there are thousands of weldings required in the car. Okay. So whether our manipulator is able to cope up with that environment. Okay. So that analysis we can do very easily with the with using FEM. And these are the list of phases involved in FEM, like pre-processing, post-processing, and regarding the advantages of FEM, specific numerical result is obtained for a specific problem. Experience and the judgment are needed in order to construct a good finite element model. A powerful computer and a reliable FEM software are essential. Computer should powerful or its analysis takes 2 days, 3 days, 4 days, even 1 week. Okay, but using a powerful high-end system, we can avoid this kind of difficulty. Input and output data may be large and tedious to prepare and interpret. If you see the matrix we get while analyzing the system, the big matrix. So dealing with that is very difficult. Numerical errors such as the limitation of the number of significant digits, rounding off occur very often. Next. Application of FEM in design of robot. So, in structural analysis of manipulator consists of linear and non-linear models. Linear models use simple parameters and assume that the material is not elastically deformed. Non-linear models consist of stressing the material parts. It's a elastic capacity. The stresses in the material then vary with the amount of deformation. In the vibrational analysis, it is used to test a manipulator base against random vibrations, shock, and impact. So in robotics, from where the vibrations comes, means what is the origin of the vibration? While suppose welding robot is there are a number of robots aligned to weld the car parts. So while dealing with the environment, and what is the environment in that case? The car body, while dealing, while welding. So whatever the vibrations will be, that will be transferred from the end effector, like we have wrist and fingers. So these fingers are end effector in the case of robotics. In the case of robotics, up to wrist is considered the part of robot. Okay. So there will be contact between the end effector and the goal point, the car body. So dealing with that, the vibrations will be transferred from the end effector of the manipulator to the base of the robot. Okay, so that can be observed in the manipulator's behavior in the trajectories, there may be deviations in the trajectories. Suppose a robot is not grounded. In that case, what will be? And suppose it robot is grounded, means a robot is a ground robot, and a robot also may be of a mobile robot, a space robot. In that case, the whatever vibrations will not be absorbed by the ground. Okay, so that will ultimately affect the trajectories of the robot, the motion of the manipulator. That's why vibrational analysis is required. And each of these incidences may act on the natural vibrational frequency of the material, which in turn may cause resonance and subsequent failure. Okay, so if vibration will not be absorbed by the ground, so there will be obviously error in the trajectories, and if there will be more vibrations, so there may be chances of damaging of the manipulator. So that's why the analysis is required. Our manipulator means the mechanical structure of the robot, whether can sustain the vibrations coming from the environment or not. Okay. The fatigue analysis helps designer to predict the life of a robot structure by showing the effects of cycling loading on the specimen. Yeah, please give me 1 minute break. I'm coming back. Please allow me. Then I will continue.
હેલો ડલ્લા સર, તમારો અવાજ નથી આવતો. યોર વોઇસ ઇઝ નોટ ઓડિબલ. હેલો હેલો Birla sir. Hello. Hello.
Yeah, I came back. Sorry for the disturbance.
So now it is audible, sir.
Yeah. So regarding fatigue analysis, in the case of robotics, so fatigue analysis, you all are aware that fatigue analysis helps designer to predict the life of a robot structure by showing the effect of cycling loading on the specimen. So while dealing with the objects, means capturing the object, the manipulator feels vibration, okay, and that vibrations can be of the cycling, loading, unloading, loading, unloading. A robot can
Sir, again you are not audible. Birla sir, you are not audible.
Participant, please bear with us. I think there is some net issue with the expert. We will just connect you as soon as he is with us. Please bear with us for some time.
Hello. Hello.
Yes, sir. Yes, you are audible now.
Yeah, suddenly I was disconnected.
Yeah, yeah.
So I was discussing fatigue analysis in the manipulator. So in such analysis, can show the areas where crack propagation is most likely to occur. You might be knowing the crack in the body is very dangerous. Okay, it is one kind of defect, and while dealing with the object, there may be failure in the manipulator. Failure due to fatigue may also show the damage tolerance of the robotic structure. Okay. And now FEM analysis of soft robot finger. This is done by my MTech student. I guided him. So firstly, the mathematical modeling of a soft flexible finger is done. So what is the finger in that case? Robotics, the fingers are the end effector. Okay, and the soft flexible fingers, like आप देखेंगे जैसे the in many cases the end effectors either may be very rigid, it may be very soft, it may be very very flexible. Dealing with the delicate objects, the end effector should also be softer, or it may damage to the object, and that object may be precious. In many cases, that object may be precious. So mathematical modeling is done taking into consideration an element of a cylindrical, soft, flexible finger. The relation of equivalent force is represented as follows. The stress, which is normal transverse stress on the soft flexible particle, is given by sigma is equal to F divided by S. F and S are contact transverse force and the contact surface area, respectively. Normal contact area pressure acting on the soft robot particle is expressed as by P is equal to F by S. Okay. So obviously, yeah, you might be knowing the difference about the stress and the pressure. Our PhD admission interview was going on. Today it is completed. I was also the member of the admission committee. We asked many times this kind of questions, and some were able to answer, but most of the participants were unable to answer. Like the difference between the stress and the pressure. The same is involved in the case of robotics also, when a minute transverse compressive force is made functional to the soft flexible particle, the radius of soft finger all along y-axis reducing. But alternatively, the width of contact maximizing. Yeah. The partial transformation in the semi-radius all along y-axis of flexible soft finger particle is expressed as the transverse compressive strain. Okay. Then from that stress we found the strain. Then by utilizing Young's modulus of elasticity, the relation of force acting on the soft flexible particle is represented as by this. F is equal to E, then del R divided by R. Geometric analysis of a soft robot finger. During effective power grasping, holding and grasping, these are the two major concerns in the gripper. Okay, so grasping, holding, we need to suppose a robot is in space. Generally, robot goes in the space and capture some tumbling object, or you can say the parts of satellite which are not in use. So to avoid a traffic problem in the space, the robot is sent, and the robot captures and decomposes the unavoided obstacles, the parts. So in that case, grasping involved a number of numerous contact surface area points exist among the targeted object and the contact surface of robot soft finger. This results maximization of load bearing capacity of power grasping system, and due to enveloping nature, it is highly stable. While capturing the objects, more number of contact points are required, and the load bearing capacity depends on that number of contact points. If contact points will be more, then grasping will be better. If contact point will be lesser, then obviously the grasping power will be less. In case of rigid finger, the twisting of soft finger at contact surface point is negligible. So far, grasping of target, the large amount of normal force is required. But a soft finger has property of deformation during grasping. But this increases the contact area. Yeah. This is the geometry of the soft robot of the finger made by my student. This is regarding analysis involved by using a finite element method. So FEA is mathematical model utilized to solve the complicated. So this already we have discussed. So further no need to discuss. Yeah. Regarding this finite element iterations, the most popular FE software is ANSYS. which is used to originate a two-dimensional FE model. The description of the modeling system used for system is Pentium. These are very basic. So, discuss. What are the assumptions we were taken? Remember, while analyzing the system, while analyzing the in the system, either it may be robotics or something else. So always we need to take assumptions. And suppose you are going to publish a paper, and if you don't put any assumptions, and obviously assumptions simplify the analysis of the system. So without, if you don't consider assumptions, so many times papers are rejected. So what are the assumptions we have taken? The soft materials were assumed to be incompressible, homogeneous, non-linear elastic, and isotropic in nature. Two-dimensional plane strain conditions were applied for the simulation. Okay, means third axis is not considered in the study. And regarding these first assumptions, incompressible, homogeneous, non-linear elastics. So generally the nature of robotics is non-linear. That's why controlling the non-linear body is very difficult. And for that, we can use either the conventional controllers like PID, PD, PI controller. And next, the 3D contact model. This is the plane strain analysis was performed by selecting 182 constituent elements in the ANSYS APDL, illustrated by the 4 locations, and each node has 2 degrees of freedom. In the robotics, or in general, a body in space will have 6 degrees of freedom. 3 for rotations, 3 for translation. In the robotics, each active degree or each active joint is considered as 1 degree of freedom. So here we are talking about 2 degrees of freedom. The selected item has properties of plasticity, high compression, toughness, maximum deviation, and maximum strength. Meshing by FEM. So after the first meshing, the size of material is reduced by the contact area as shown in the figure. Refinement in the contact surface area is done in a manner that the contact surface area must not be exaggerated. The deformation by FEM, the ANSYS internally manages the increased load to get it integrated the solution. It continues until an integrated solution for the loading applied. Soft finger rotation is calculated at the orientation point, the node corresponding to the upper part, and the connection width was measured depending upon the numerous elements encountered by the solid plane. Yeah. So this is regarding stress analysis we have done, and this is regarding deformation FA results of finger. So it says the FA results of finger and the Ogden finger models, constraints and the test results. So our main focus is here regarding the nature of deformation. 0.02% deviation is noted between FE results of fingerprint model of neoprene and Ogden manufacturer and the experiments result. So in this way, we have done the deformation analysis in the manipulator. So this part I am going to conclude. Then a little bit I will give exposure of another software so that motion of the robots can be fed. So what is the summary of this task? A little task is done with the help of my student. The variation of contact with and the deformation with applied normal force ranges from 0 to 100 Newton were determined. Inclined tests were conducted for each soft finger against target material. It is to determine the frictional coefficient between them. Numerical simulation was done for the semi-cylindrical soft finger and successfully validated with experimental results. Numerical simulation was done for semi-cylindrical. Yeah, this is done. Now, the another part I am giving exposure that is related to the software. I will complete it quickly. This what I have discussed, that is for analysis of the deformations, stresses, strains involved in the manipulator. Next to the motion part, like kinematics and the dynamics, that can be visualized by using this software RoboAnalyzer. And before that, I wanted to say regarding that, if one is interested to find the published paper of mine related to FEM in robotics, so one can search my name in the Google. Then one can get my biodata, all informations, email ID, mobile numbers, and publications. And another thing, from the Google Scholar, this is a finite element analysis of fundamental deformation of robot soft finger. This can be accessed. If one is interested, then one can go through this paper. And regarding the software, which may be very useful, the Robo Analyzer. This software, the Robo Analyzer is a 3D model based software. So how to download the software? So one can go in this page and can download the software, the latest version. Okay. Now coming to the software, and this software is open source, not commercial. So especially the mechanical engineering students, or it is also for faculty members, those are interested in the robotics field, are simply for showing the motions, giving example of kinematics and the dynamics. So this is the best software in which the motion can be visualized by either 3D model or by the graphical presentation. Okay. So 3D model, here these are the inbuilt robots. So from 1 degree of freedom to 7 degrees of freedom, robot we can access. And these are the types of robots, like the types of joints, prismatic, either prismatic or revolute. So you can see if there are 2P means 2 prismatic, 2R, 2 revolute, PR, prismatic and revolute. RP means first joint is revolute and second joint is prismatic. Suppose we want to access 5 degrees of freedom robot, and also in 5 degrees of freedom there are 3 inbuilt robots. Let us load this one. So it is the 3D model of the robot, and what we wanted to know here, the motion we want to visualize. The earlier what I have discussed, that is analysis of the, you can say, stresses, strains developed in the manipulator. But that is ultimately used for providing motions to the manipulator. So that motions I'm going to study, I'm going to talk. So for that, we need to know forward kinematics, we need to know inverse kinematics. So in forward kinematics, what we need to find out? In forward kinematics, we want to know about the end effector positions for the given joint variables, joint angles. But in the case of inverse kinematics, we want to know the various set of joint variables. What are the joint angles to reach the certain goal point? मान लीजिए आपको वेल्डिंग करना है, मान लीजिए आपको कुछ पाइप के अंदर इंस्पेक्शन करना है, आपको मीन्स रोबोट. So for that we need to have multiple degrees of freedom, means number of joints. So what will be values of that joints? That can be found by the inverse kinematics. Okay. So I am doing here now. The time I have given 1 second. It can be increased. It is of software age, not commercial till now. So anyone can access this software. Yeah. Number of steps I have given. Then I'm clicking the forward kinematics. So see, the analysis is complete. Analysis is complete means equations are developed. Then now we can see the motion by playing this animation. So see the motion of the manipulator of the robot. और यही robot का, for example, we have analyzed how much payload it can bear, it can cope up. So that analysis can be done by using FEM. And here also the analysis is done by using numerical methods. By using numerical methods. So see, regarding this motion, it is the trajectory of the robot. Trajectory of the robot. So this motion is visualized by seeing. Also, this can be visualized by this graph. Our main focus is to know about the positions of end effectors. So that is found how the nature of end effector motion, from where it is started, whether it is going up in the positive or negative directions, like above zero values or below, and where it is, what is the maximum values of the end effectors, means the position of the end effectors can be found from this graph. Okay. So as I told, there are two ways to know, to visualize the motion of the manipulator. One is by the 3D model and the other is by graphical representation of the result. And inverse kinematics, what we find out? We find out the joint angles. So for the given end effector positions, x is equal to this much, 0.35 meter, y is equal to 0.1 meter, z is equal to 0.5 meter. So what are the various set of joint variable? Why I am saying a set? Because this robot has 6 degrees of freedom. So if I click this inverse kinematics to see how many solutions, number of solutions in this software, only 8 solutions are displayed. So 8 solutions we have right now. Okay. Means, what is the meaning of this? 8 solutions we have. The positions are fixed. The end effector positions are fixed. Like आपको जैसे रोबोट को, बाय द वे, आपको नट को टाइट करना है. नट को टाइट करना है, so there will be some specific locations, and it doesn't matter which path is followed, but location matters. Okay, so which path is followed, that is determined by the these joint variables. These joint variables. So suppose I take values of this solution 1, then see what is happening. If I take solution 1, then my configuration of the robot means how it looks like, means what is the position and the orientation of the manipulator. So by taking these values of solution 1, it looks like this, and suppose I am taking values of solution 5, then see, is there any changes? Obviously there are changes, and you just observe the changes. Solution 2, see, solution 7, yeah. So various configurations we can get by loading the various set of joint variables. So this inverse kinematics is also done. However, you will be saying what is the connection of FEM with this? Yeah, I accept that there is not a direct connection because, but we can connect this analysis of the manipulator can be done by FEM, and how much a payload is able to bear, that can be done by FEM. Whatever analysis is done here, like after clicking see here, analysis is complete. Is by using numerical methods, approximation methods. So FEM is also based on approximation method. Okay. One more thing I want to give exposure, that is very good things one can enjoy. Faculty members use this software for the better visualization of the robot. If you don't have real robots, mainly in that case, it is very useful. Yeah. This robot, by default, this ABI, this is the model name of this robot is coming to display here. You can select various robots, like suppose I am going to select this KUKA made in India, this robot. I'm going to load. Yeah, it is being loaded. Yeah. So we can control this robot either by the controlling joints or by controlling end effect. So by controlling joints, we can identify some. In some cases, it is very difficult to identify which one is joint 1, 2, 3. So in that case, like this is easily one can identify the joint 2, joint 3, joint 4, joint 5, joint 6. In this way, we can control the joints. Now, coming to the home position, means ये home position में आ गया robot. Now, so the Cartesian control the end effector. And suppose I am increasing the increment. This I am doing. Okay. Now, for doing manipulation, a certain path is required. So how to how to trace the certain path. So this I'm going to do. I am clicking. This is the limit of so better. Yeah, better to go. Yeah, in this way, just taking too much time. Okay, once again, let us. This I'm putting here 3. I'm just putting 2. Okay, and see the traces in the, you can say, workspace in the screen. I'm clicking X minus icon. Our purpose is to make a rectangular, or you can say to follow the path of rectangular. Okay, we need to now go this. In this way, we can close the circuit. Close the circuit means we will be able to get the rectangular path by closing the circuit. Yeah, in this way, either we can control our manipulator through the joints or through the AND effectors, means Cartesian control. So in this way, I try to give some things what I could do to the best of my efforts. I try to give something, I try to expose, I try to share my knowledge with the participants. However, I was totally not focused with the FEM in robotics because there is some technical problems. But I tried to give something that you can enjoy and you can take it as reference for the visualization of, suppose if you want to visualize the motions of the manipulator, then obviously you can choose this software, and it is open source, so anyone can access without any difficulty. So with this, I would like to say thank you. But before that, you can interact with me. But I would like thanks to coordinator Dr. Modi and your institute and dear participants. Thank you for bearing me. If you want to interact with me, so please you can interact. You're welcome. I have done from my side.
Dear participants, your mic is unmute. Please ask the questions if you have.
The software name is RoboAnalyzer. For FEM analysis, one can use ANSYS. Yeah, if you don't want to interact right now,
Okay.
so yeah.
Yes, sir. I hope the participants will interact with you if they have any questions through email.
Yeah,
Thank you.
definitely.
Yeah.
You can interact with me if you have any whether personal or professional problems. If you want to discuss with me, so you are always welcome. I have also my YouTube channel, Vijay Dalla. If you search in YouTube, so you will find me. I am also in Facebook. Also, you can connect with me. There are many cases where we can interact, and our interaction is required. Not only from your side, I may also require to interact with you. So without any hesitation, you can interact with me anytime, whenever you want. Yeah, ma'am.
Yeah, thank you so much, sir. Thank you for the informative session and also for all the resourceful information you have shared in this session. You also delivered this in session with full enthusiasm. Thank you so much, sir. And we are very graceful to have you. And on behalf of our team from GEC Bharuch, I thank you so much, sir.
Yeah, thank you, ma'am.
Yes, sir. Thank you.
Yeah, thank you.
Dear participants, please be connected at 3 p.m. The link will be shared in WhatsApp and MS Teams chat box also. The session, this test will be or quiz will be for 1 hour. 100 marks test will be there with 50 questions, each of 2 marks. So please be connected at 3 p.m. A very good evening to our Honorable Chief Guest, Dr. Sachin Parikh, sir, Joint Director, Commissionerate of Technical Education, Government of Gujarat, Respected Dr. Sanjay Joshi Sir, College Bharuch. Respected Dr. Ratnesh Shukla Sir, Head Mechanical Engineering Department, Government Engineering College Bharuch. All respected Head of Departments from GEC Bharuch, dear faculties and dear participants. I, Deepa,
Ma'am,
on behalf of...
ma'am,
Yes, sir.
we are waiting for Sachin sir.
Okay, so just tell me when we shall start, sir.
Sure, ma'am.
अरे
Okay.
मैडम ओ दीपा मैडम हेलो
Yes, sir. Yes, sir. Yes, sir. You are audible.
We should say we are waiting for Sachin Parikh sir.
Okay. Yes, sir.
Yes, Deepa ma'am.
Yes, sir.
Our chief guest, Dr. Sachin Parikh sir, is with us.
Okay, sir.
You may start, ma'am.
Okay, sir. A very good evening to our honorable chief guest, Dr. Sachin Parikh sir, Joint Director, Commissionerate of Technical Education, Government of Gujarat. Respected Dr. Sanjay Joshi sir, Principal, Government Engineering College Bharuch. Respected Dr. Ratnesh Shukla sir, Head Mechanical Engineering Department, Government Engineering College Bharuch. All respected Head of Departments from GEC Bharuch, dear faculties and dear participants. I, Deepa Pandey, on behalf of organizing team Mechanical Engineering Department, GEC Bharuch, welcome you all to the valedictory function of AICT sponsored online Atal Faculty Development Program on elements of FEM. Before we proceed with the program, I would request our FDP coordinator, Professor Ashish Modi sir, to please give the overview about this 1 week program.
Thank you, madam. Respected Dr. Sachin Parikh sir, Joint Director, CT Gujarat State. Respected Principal sir, Dr. S.R. Joshi. Respected Head of the Department, Dr. R.K. Shukla sir. Respected all heads of various departments of GEC Bharuch. Dear all colleagues and my dear participants. Good afternoon to all. As anything that starts well ends well. As said at the inaugural function of the FDP, this FDP is intended to focus on elements of finite element method in the structural, thermal, and fluid domain due to their increase in demand in various engineering areas. Eminent experts from both industry and academics were invited for delivering expert sessions. I am very much thankful to all the experts for conducting sessions and solving most of the queries raised by all the participants. I am sure that all the sessions will be helpful to all the participants to understand the basics of finite element method and its various applications in engineering domain. our entire FDP team tried their level best to make this FDP fruitful for every participant. From the day of making proposal of this FDP, I am thankful to my departmental FDP team for planning and execution. I am sincerely thankful to Dr. S.R. Joshi sir to motivate us for proposing and organizing such kind of FDP and showing trust on us. For FDP, we got immense support from all the participants, AICT Atal Academy New Delhi, experts from various institutes and national organizations. And how can I forget my departmental faculty members from GEC Bharuch, especially thanks to Dr. R.K. Shukla sir, Dr. H.K. Solanki sir, Professor Vimal Patel sir, Professor Vasant Patel sir, Professor Ashfaq Sheikh sir, Professor B.C. Pathak sir, and Professor Deepa Pandey madam for their unconditional support. I would like to bring in kind notice to our honorable chief guest, Dr. Sachin Parikh sir, that our FDP become highly popular in terms of participants in registration. Total 200 participants were registered, and from that 180 were selected. We got participants from every state all over the India. There were 14 sessions excluding inaugural and valedictory ceremony. Dr. Rupesh Shah sir, Associate Dean Academics from SPNIT Surat, has graced our inaugural function as a chief guest and a session expert for the first session. Eminent speaker and subject experts, Dr. H.B. Mehta sir from SPNIT Surat, NIT Jamshedpur, Dr. Ramesh Kumar Gupta sir from Shiv Nadar University, Delhi NCR, Dr. Manoj Kumar Gupta sir from Institute of Plasma Research, Ahmedabad, Dr. Chaitanya Desai sir from CK Pithawala, Surat, Dr. Parag Rajpara sir from Marwadi University, Rajkot, gave their full support to make this FDP successful. I conducted hands-on training program along with our industrial guest, Mr. Kailas Jagtap from ARK Infosystems and Mr. Jigyasu from Integrated Microsystem. Here, this hands-on training was mainly focused on finite element analysis using ANSYS software. Being coordinator of this FDP, I myself and Dr. Hitesh Solanki attended all the sessions of FDP. All sessions delivered the basics of finite element method at the elementary level. We hope this FDP will be fruitful in future to all participants in their academics as well as in research activities. All sessions having good strength of participation, and also participants were eager to interact with the experts. All the sessions were found very interactive, interesting, and highly informative. The FDP was organized on MS Team platform, and all the sessions were online live telecasted on YouTube also. I am not taking much more time because today we are interested to hear a lot from our participants. Herewith, I am welcoming our chief guest. Thank you all. Please, Professor Deepa Pandey madam, kindly go with the further proceedings.
Thank you so much, sir. Let us proceed with the event now. I would like to invite our respected principal, Dr. Sanjay Joshi, sir, to welcome our chief guest, Honorable Dr. Sachin Parikh, sir. I will also request Dr. Sanjay Joshi, sir, to motivate us on this occasion. Sir, please.
Thank you, madam. Dr. Sachin Parikh, Joint Director, Establishment, Commissionerate of Technical Education, Government of Gujarat. Dr. R.K. Shukla, Professor in Mechanical Engineering, GEC Bharuch. The young and dynamic coordinators, Dr. Hitesh Solanki and Ashish J. Modi. Other faculty members of the department of my institute, and this is really a great occasion to say something on the validity function of the FDP under the Atal initiative of AICTE. Bharuch, we are very much active and interested in conducting such kind of valuable and effective FDP. In the series of those FDP, this is the 5th FDP conducted at GEC Bharuch. The level of quality content delivered by the all experts of this FDP was really of high standard. The organizational skill of both these young and dynamic coordinators is really excellent. I have personally witnessed and monitored this quality of these coordinators. The hands-on sessions were also very much useful to all the participants. I believe that delivery of such extremely good quality of content in this area of FEM shows the high level of technical competency of the coordinators as well as the other experts of this FDP. The sessions were nicely planned and conducted also. So I congratulate these both coordinators and head of mechanical engineering department. Sachin sir, this is not the last FDP which we have conducted. Not only FDP, we will be conducting many more such good academic activities at this institute. The support of DT has been really extremely good. They have deputed many faculty members in this FDP from the Gujarat state. So that has also contributed in success of this FDP. So once again, I congratulate coordinators and the experts and the other faculty members, those who have contributed in organization of this FDP. Now I say something on Sachin Parikh sir. He is very young, dynamic joint director we have got in DT in recent last few years. He has been actively involved in the administration of technical education department of Government of Gujarat. Basically, he is professor of chemical engineering. He has came to the department through GPSC, but prior to that, he has successfully run the VVP Engineering College as a principal for many years. So he is very much skilled and highly competent authority in the Gujarat state. I am very happy to share with you that the GEC Bharuch is happy to host him in valedictory function as chief guest. I know that these days he is extremely busy, though he has accepted our invitation and spare his valuable time. So I am very much grateful to him. Thanks a lot, Sachin Parikh sir, for joining in the valedictory function. Deepa ma'am, please go ahead. Time is a major constraint for him also and for me also. So please,
Sure,
Deepa.
sure. Yes, sir. Thank you so much, sir, for your inspirational words, which keep us motivating to conduct such programs. I feel privileged to invite Dr. Sachin Parikh, sir, to grace us with your valuable words. Sir, please.
Yeah, thank you so much, madam. Respected Joshi sir, Ashish Modi sir, all faculty members of GEC Bharuch, and dear participants, it is a privilege for me to remain present as a chief guest in the valedictory program of Atal Ayojit FDP on FEM. As Joshi sir has said, we are extremely busy, and also at your institute also on 1st of August, there is a program, what we call it as a Gyan Shakti Divas. So I am sitting right now in the main venue, that is at Mahatma Mandir, and attending this valedictory function. Also, it is my privilege to attend valedictory or inaugural program of, I think, 3rd or 4th FDP in a very short span of time. And also I also delivered one expert lecture in one of the chemical FDP. So I'm very happy that Joshi sir focus is mainly towards upliftment and improvement of the academic standard, or I should say, you all are moving towards academic excellence at a place at Bharuch. So that is really an admirable thing. I, on behalf of me, I give all the best for the future endeavor. And Joshi sir rightly said, this is yes not the last FDP, because if a person is working hard, always the authorities or the bodies were having more expectations towards that person or towards the group of people. So our expectations increases day by day, and we are very much confident that under the able leadership of Joshi sir, GEC Bharuch will reach new milestones in a year to come. Regarding this topic, it reminded me when I was doing my PhD. It was on work. I worked on multi-phase flow. So that time also I was planning to use finite element method, and fortunately I got one very good software and help from the MFix. The creator was basically a South Indian scientist, and he was working as a professor in one of the leading university of US. So it helped me in writing one of my chapter in my thesis, and and also published a good paper. But my advice to all the participants who are attending this program is this, techniques, mathematical techniques, and the softwares are really very good, gives very accurate results. But when you are guiding a students, or when you are doing some kind of PhD work, always make a work of always combine experimental work with this mathematical work. Don't only focus either on experimental work or either on mathematical work, but do the work where you can compare your experimental data with the simulations outcome. That will give a good confidence, and you can proudly present this work to the our teaching community, that simulation, through simulations, whatever the data you get, it may happen that it is having more ideality. But when you are comparing those data, those outcome which is generated with the experimental results, that you then at that time you get how much accurate your experimental, either your experimental work, or how much it is closer to your real work. So I'm really sorry, I wanted to say so many other things, but time is very limited, and we are here for doing some giving final touch to the main program on 1st of August. So once again, I thank you, Principal Sir and whole team, for inviting me in this valedictory function of this FDP. Thank you very much. I take the leave of all of you. Thank you.
Thank you so much, sir, for the motivation and appreciation, and also sparing your valuable time for the event. Sir, we are truly overwhelmed with your presence. Thank you so much, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir. I now invite Dr. Ratnesh Shukla, sir, Head of Mechanical Engineering Department, Government Engineering College, Bharuch, to address us with his kind words.
Now we are coming to this end of this one big long FDP. So first of all, I'll like to thank Dr. Sachin Parikh sir for sparing his valuable time, and Principal sir. Both are busy with the celebration of the Gyan Shakti Divas. So so in spite of this busy schedule, I'll thank them for sparing the time. I also thank AICTE Atal Academy for giving grant of around 93,000 for this our FTP. Both the coordinators, Ashish Modi and Professor Hitesh Solanki, they have worked very hard to make this FDP a success. regarding this, as Sachin Parikh sir told, that for the PhD work, many faculty are doing the experimental work, but then it has to be compared with the experiment with the software, because both the data should match. So this will be very much helpful for the faculty who are participating, and their knowledge will be definitely enhanced. So considering the time constraint, I will not talk much. Over to Deepa madam.
Thank you so much, sir, for the motivation and kind words. We are now eager to hear from our dear participants. We are getting so many of the what we say good valuable comments from you, but I want everyone to please participate and give honest and valuable feedback regarding this FDP. Please, dear participants.
Okay, good morning, good afternoon. It's Venkat Ramanan from Tamil Nadu Sona College of Technology, Salem in Tamil Nadu. Yeah, the way of session, all the sessions are very good, and I gather a lot of information regarding this finite element analysis, and I know something about the Abacus and then ANSYS software, and then it should be very useful because all the sessions are very practical oriented, and then I gave a lot of information because a lot of things are taken from J.N. Reddy and other some valuable books. So the session you are organized and the time you have maintained all are good. I really thank for conducting this Atal FDP from this Bharuch Government Engineering College. Thank you. Thank you.
Thank you, Venkat
Thank you,
Raman
sir.
sir.
Thank you.
I would request other participants also to please give your feedback. It will be very valuable for us.
Good afternoon, sir and madam. My name is R.S. Kiran. I'm speaking from Visakhapatnam. The FDP was very well organized by the organizers and their team members. Great sessions, and the sessions were very informative. The FDP was simplified, very specified, standardized, and diversified to make it useful for all fields of research areas. And I hope to find more practical applications in the future for the areas of research related to STEM applications, namely science, technology, engineering, mathematics, management, and medical fields. So I thank all the organizers, I thank all the team members, I thank everyone with whomever I have interacted and I have heard the lectures, and I thank everyone. Thank you, madam. Yes, sir.
Thanks, RK sir. Anybody?
Good evening, sir.
Yes.
Good evening, all. Myself, Amar Mathur from West Bengal, and I was very happy that all the sessions were running smoothly, and I am very much eager to looking forward for more FDP from Bharuch itself, and all the behaviors from the faculties as well as ma'am on all the faculties. They have really supported me, and when I was personally messaging or texting, they were really supportive. And I am eagerly waiting for more FDP to come. This was my first FDP, and therefore I am very much eager to waiting for more FDP. Thank you.
Thank you, Amar sir. Yes, Dushyant bhai.
બોલો તોય એમને કશું કોઈ કેર નહીં એમ ન્યૂઝ એમને સ્પેશિયલ આપવા જવાના.
Good afternoon, sir.
Yes, ma'am. Yes,
Can
ma'am.
you hear me, sir?
Yes, yes. Ma'am, kindly mute yourself. Kindly mute yourself.
Okay. Good afternoon, sir.
Yes.
I'm Dr. Harinakshi Karkera, faculty from the Department of Mathematics, Manipal Institute of Technology. So I'm very happy and grateful for you for giving me an opportunity to be in this FDP. I have seen the FDPs related to finite element method, because that was one of the area where I would like to work more along with the wavelet concept. So when I saw there the as finite element method is a little complicated. Even the way of explaining also was happened to be complicated in those. But whereas this FDP, not hyperizing, this is a fact in this FDP, starting from the first day that Dr. Rupesh D. Shah sir, the way he has explained, that is actually for a student. We are actually a student of FEM. So I wrote the notes and I'm so happy. I would like to recall those notes once again by looking into the recordings once again. So such a wonderful way of organizing also. So what you mean to do, actually you already did it and you achieved also, sir. I'm so happy. Thank you very much, sir. Thank you.
Thank you, madam. Thank you very much. Anybody else?
Hello.
From participants? Yes.
So this side Ganesh Kumar Sharma.
Yes.
From my point of view, this FDP was very awesome, and I have learned so many things in FEM because I am doing also work in PhD in FEM. So some basics and 1D, 2D modules and some software analysis. I have learned so many things. So from my side, my warm thanks to all organization and college also. Thank you.
Thank you, sir. Thank you very much. Anybody else?
One request from my side.
Yes, sir.
Sir, if possible, if you kindly provide a lecture session of all the session there, if possible.
Sir, we try to collect the PPTs as well as we also try to share you the video links regarding the FDP.
Okay, sure. Thank you.
Yes, any participant who will like to give comments or feedback on from Gujarat state. Any other participants still if want
Hello.
to give? Yes, sir.
Hello.
Yes, sir, you are audible. Yes, you are audible.
Okay, madam. I am from Mehsana, Gujarat. All sessions are very well and well going on. And just request to whenever next time conducting this type of session, so more the session of like ANSYS 2, 3, 4 hours. So we actually getting the practice from the ANSYS. Hello.
Yes, sir.
Yes.
Okay, sir. Thank you.
So earlier we are
Sure,
planning
sir,
this. 1 minute, madam. Sir, earlier we are planning for offline FTP using ANSYS software, but due to this Corona situation, we are converting that FTP in online mode, and we are grateful to Atal Academy that they provide us a platform for online FTP, conducting online FTP.
Sure, sir.
Okay, sir. Ma'am.
Yes. Any other participants would like to give comments or feedback?
Ashish sir. Hello. We can invite feedback from our own faculty, GC Bharuch, who are deputed in this FDP.
Hello. Am I audible, sir?
Yes, sir. Yes.
Myself, Parekh Ravi from EJ Polytechnic, Bharuch, from Mechanical Department.
GEC Bharuch is always great for me, and from my graduation to till today, it's always something like Makkah of education for me. So thank you all the faculties and coordinators and head of the department sir and principal sir for organizing such a great FDP for me, because the finite element methods, these particular FDP will also helpful for me in future for my personal and as well as for my PhD work also. So once again, thank you, sir, and I'm always looking forward in a future also to participate in a such a FDP organized by GEC Bharuch. Thank you, sir.
Thank you, Parekh.
Thank you so much, Ravi sir. Thank you so much.
Hello, Deepa madam, am I audible?
Yes, sir.
Yes, sir, you are audible. Please, sir.
Yes, madam. First of all, I would like to say that all the sessions are full of informative, and especially I would like to say that the session given by the Dr. Parag Rajpara sir, that is very helpful to particularly me, as I am right now doing the research work in the combustion side, gas turbine combustion side. So that topic was very helpful to me. And also the session given by the Kailash Jagtap sir, hands-on training, that is also very helpful. Thank you, sir.
Thank you so much, sir. Any other participants would like to give any feedback? Okay, so I think we should now proceed for the other.
Sir, myself, Kishan Patel from the
yes,
VPMP
yes.
Polytechnic. I say this program is a wonderful program, and this is the best opportunity to learn the FEM. And sir, this all module cover in within 5 days. I hope this is a shorter time to learn. Am I right to speak to you? Right now,
Yes,
sir?
yes,
Sir.
yes.
Yes. So, if the possible, please send us the other detailed guidance link or the other YouTube video link to us for learn the at our free time.
Yes, sir.
Thank you,
Definitely.
team, and thank you, sir. Then all the professors. Thank you.
Welcome, sir.
Thank you, sir. Yes, I would invite other participants also if they want to give feedback. Please, you are most welcome. Okay, it seems I should proceed with the event now. There are many feedbacks and many much comments, positive comments on the chat box of MS Teams also. We thank all the participants for this, being patient with us. They have been very cooperative and disciplined. Thank you so much, all of you. I now invite Professor Chirag Makwana, sir, Associate Professor in Mechanical Engineering Department, Government Engineering College, Bharuch, to propose a vote of thanks. Sir, please.
Thank you, ma'am, for invitation. Good afternoon, all. Myself, Professor C.K. Makwana, Associate Professor, Mechanical Engineering Department, Government Engineering College, Bharuch. I am really gratified for giving me a chance to deliver a vote of thanks on a valedictory function of this activity. It was really a great time with you. I am sure that you gained a lot from this activity. First of all, I am thankful to Almighty for giving us courage and spirit to arrange this glorified event. His blessing has turned this event into grand success. On behalf of the team member, the coordinator of this FDP, head of the department, Dr. R.K. Shukla sir, and our beloved principal, Dr. Sanjay R. Joshi sir, I pass my warm thanks to AICTE Atal Academy for giving us opportunity to conduct such wonderful FDP, for providing fund for that.
And on behalf of the Mechanical Engineering Department and organizing team, I am thankful to respected Principal Sir Dr. Sanjay R. Joshi Sir for their motivation to conduct such event. His guidance and enthusiasm prompted us to organize this event. Without Joshi Sir's support, guidance, and motivation, it was truly impossible to organize such FDP. Thank you, Joshi Sir. On behalf of Government Engineering College Bharuch, I am thankful of our chief guest, respected Dr. Sachin Parikh Sir, Joint Director, Commissionerate of Technical Education, Gujarat State, for his presence in this event and their valuable support whenever required. Sir, thanks a lot for sparing precious time from your busy schedule. It really means a lot to us. I am thankful to all the participants for their significant presence in this FDP, because without the help of a participant, their presence, it is not possible to complete such a wonderful FDP. Thank you all participants. I also want to say thank to all the speakers who have given best from their side on FEM. I want to appreciate their effort to make this event informative for all of us. I also thank all team members who worked hard for success of this FDP. They performed their duty really gracefully. I would like to express my hearty thanks to all the people who worked in background. They really put their zeal and zest to make all the preparation related to this FDP. I thank all members of our department and institute. Their combined effort have borne fruit, otherwise it would be impossible. Their strong unity and high spirit made this event highly successful. At last, once again, a warm thanks to all the people associated directly and indirectly with this FDP for making this event a grand success. Thank you all. Thank you very much. Over to Deepa ma'am.
Thank you. Yeah, thank you so much, sir. As a participant of this FDP and member of Mechanical Department, I heartily congratulate the coordinators, Professor Ashish Modi, Professor Hitesh Solanki sir, and the entire team for making this FDP possible. I finally thank you all on behalf of our team for your admirable presence in this occasion. There are few instructions to be given by Professor Ashish Modi sir. Sir, please continue.
Okay, dear participants, there are few instructions from my side. Surely I will provide all the materials from expert and videos which we recorded in our expert sessions. So I will share it within 1 to 2 days. Okay. The main announcement is that all the participants are requested to kindly fill the feedback form at the Atal portal regarding our FDP. Then and then the participants can get their certificate of completion for this FTP. Okay, so you have to fill this feedback form today itself after completion of this valedictory. Kindly fill it. There are more suggestions that can we know our attendance and test mark status? Yes, definitely. After completion of STTP, I will share your attendance as well as test marks in our WhatsApp group only. Okay, and you can check both marks and attendance on Atal portal also. Okay, when you feel the feedback, you can check or observe your attendance and test marks in Atal portal. So do not forget to give feedback on Atal portal. If you face any difficulty, you can contact us. Is there okay with you? Anybody wants to ask something? Any query from your side, dear participants? Okay, so There is one question: how many days it take to update marks in Atal portal? Yes, we updated marks in Atal portal, and as per their rule, they will shown the marks will be shown in Atal portal. So this is our first time FDP at Atal portal, and as per our knowledge, it will be shown within 24 hours. Any other question? Yes, sir.
So congratulations to both of you, the mechanical department, the leader of the department, and all participants.
Thank you, sir. Thank you very much.
Very good efforts, highly appreciated.
Thank you, sir.
Good, keep it up.
Thank you very much, sir, for kind words.
I expect many more FDPs from you.
Yes, sir.
Sir, when can we get the certificate, sir? Today, or it would take some more time?
Sir, as per AICTE Atal portal rule, they are giving FDP after submitting your feedback, but it will take highly 2 to 3 hours to generate, or it is definitely within 24 hours with you.
Okay, sir. Thank you, sir.
Other formalities from our side, we will complete it within these 1 to 2 hours from our side.
Thank you, sir. Thank you very much.
Sure, sir. Chavan, sir. We will share it. We will share it. Okay, from these words, I am concluding this FDP, and I I give my sincere thanks to all the participants to join us and participate in our FDP. Thank you very much, and we hope we hope for the participation in our future FDPs also. Thank you very much, sir. Okay, all the participants, yes. Ma'am, please go ahead.
Yes, sir. Yes, yes. Any instructions still to be given, or shall we conclude?
Yes, ma'am, you can conclude.
Okay. So before we leave or conclude this program, please, I will request all the participants to put on their cameras so that we can have a photograph. Please switch on your cameras, dear participants.
Madam, give access to the camera opening.
Ma'am, when will you receive the certificate?
Team members, kindly take a picture.
आपको सब कल दे दीजिए इसको नहीं देता मैं बस मेरा बहुत सारा डाटा है आपका कल देखो
Okay, sir. Thank you, all of you. And with this, we conclude the valedictory function. Hope to see you all, and all wish you all in good health. Thank you.
All the participants, do not forget to fill feedback form on Atal portal. This is my humble request to all the participants. Kindly fill feedback form on Atal portal by logging your own credentials.
मेरे नाम से बोलना लैपटॉप
मेरा
वापस देगा ये खेला करते बट
थोड़ा आज मैं टाइटल बना उसके ऊपर
आगे जाना कितना जाना
क्यों
यहाँ निकल रहे तुम्हारा डब्बा
वहाँ किधर
मेरे में बैग में डब्बी
पकड़ो।
अच्छा करो
ஹலோ, ஆமாம் சார், நீங்கள் வேலேஷன் போயிட்டீங்க, அப்புறமேட்டுக்கு ஹைட் ஒர்க் எல்லாம் பார்த்து பண்ணிட்டீங்க. நான் உட்காந்து கிளாஸ் நடத்திட்டு இருக்கிறேன் 5 மணி வரைக்கும். ஆமாம், ஹைட் ஒர்க்கு இப்போ கூப்பிட்டுருந்தாங்கல்ல, அந்த இது ப்ரோ அதுலேயும் பேர் கொடுத்துருக்கீங்களா? நீங்கள் சொல்லாம யாராவது கொடுப்பாங்களா சார்? சும்மா கருவாதீங்க சார். நீங்கள் உட்காந்து சம்பாதிக்கணும், உட்காந்து கொடுக்கலாம், நாங்கள் கிளாஸ் எடுத்துருக்கோம். சொல்றேன்னா கேட்பேன். அவர்கிட்ட நீங்களும் ஒரு லட்சம் சம்பளம் வாங்கினா நான் உட்காந்து ஃபீஸ் கலெக்ஷன் பண்ணுவேன். இதெல்லாம் புதுசாக வாங்கிட்டு உட்காந்து ஃபீஸ் கலெக்ஷன் பண்ணிட்டு உட்காந்துட்டு இருந்தாங்க. எல்லாமே பண்ணிக்கிறீங்க நீங்க. பணம் வரதுக்கு உண்டான வழி, நல்ல பேர் வாங்கறதுக்கு உண்டான நீங்க எவனோ ஒரு பைத்தியக்காரன் உட்காந்துட்டு ஏதாவது உட்காந்து நடத்திட்டு இருப்பான். அன்னைக்கு வந்து அவ்வளவு தடவை சொல்றேன் சார், நாமக்கல் போயிருக்கு சார், கூப்பிடாதீங்க சொல்லிட்டு தான் போறேன், இல்லவே இல்லைங்க. ஏன் நான் சொன்னேன்னு உங்ககிட்ட சார், நாயை கூப்பிட்டு போயிருக்கேன் சார் அப்படின்னு சொல்லிட்டாரு. நான் உங்களுக்கு தொந்தரவு பண்றேன். இப்ப நீங்க போய் வேல்யூஷனுக்கு தான் போறீங்க, அதான் கேட்கறேன். நான் சொல்லுங்க, நான் பாட்டும் பேசாம நடத்திட்டு இருக்கிறேன் கிளாஸ். ஏன் அத்தனை தடவை ஃபோன் பண்ணுவாங்க, நான் தான் சொல்றேன் சார், நான் வந்து பைபாஸ் ரோட்ல நின்றுட்டு இருக்கேன் சார், தயவு செஞ்சு ஃபோன் பண்ணாதீங்க சார்ங்கிறேன். நீங்க வந்து கேட்காம திருப்பி பண்ணிக்கிட்டே இருக்கீங்க. நான் ஹாஸ்பிட்டல் இருக்கிறேன்னு சொல்றேன். ஏன் யாரும் வாங்கி கொடுத்தா? நீங்களா வாங்கி கொடுத்தீங்க? நீங்க அதை